Hello, guys, and welcome to our first data analysis class. We are going to the real data analysis now. In this class, we're starting with the very first and most basic analysis, that is descriptive analysis. Believe me, there is no this thing you want to do that you will not need any analysis you want to do that you will not need to first of all describe your data set. And as I promised you people earlier, I said during this course, I'm going to first of all start with what the theory, so that by the time the practical parts start coming in, you first of all understand how it works, and you also understand how to interpret your data and what each result means. So let's head on straight now to data analysis, to descriptive statistics. Now, descriptive statistics are broadly divided into two parts. You have the measures of central tendency and the measures of dispersion. Now, the measures of central tendency gives us an idea of how the middle or the central of that data looks like. For instance, our mean tells us, mean is the same thing as average, tells us the average of the data set. The median tells us if you arrange the data set from the biggest to the smallest, the one in the middle. And our mode tells us that which one is occurring the most. Now, normally the one that occurs the most should be something in the middle. The same thing then for measures of dispersion tells us how sparse our data set is. For instance, our variance tells us how much each data set differ from the the mean of the data set. And standard deviation is just the square root of variance. Our range is the tallest, the highest minus the shortest, the biggest minus the smallest, which gives us an idea also of how much the data sets vary. That's why it's called measure of dispersion. How sparse are these data sets? While our interquartile range tells us the difference between the 25th quartile and the 75th quartile. What does that mean? If you arrange your data set, the 25th percent of your data set minus the 57th percent of your data set, that is, if they are arranged accordingly from the smallest to the biggest, find the difference, and that will give you your interquartile range. Now, I want you to look at descriptive statistics as if you are describing somebody. Let me just give. Let me see if I say, okay, hey, hello, see this guy. This guy is tall, he's fair. Um, he's tall, he's fair, he's chubby. You understand? You already have a mental picture of the kind of person I'm talking about. The same thing goes in statistics. If you are describing your data, whoever is seeing it should have a mental picture of what you are describing. So if I say, for instance, the height of people in Chinese is 4.8 feet, while the height of people in South America is 5.2 feet. Automatically it means that the mean of the height. So automatically it already gives you an idea that the people in Chinese are shorter than the people in South America. Now, if I now say that the variance of the height of people in Chinese is 1 feet, while the variance of the people in South America is 2 feet, it means that the people in Chinese, their heights are all closely related. They don't vary much. But the people in South America, since the variance is bigger, it means their height vary much. That is the same thing for each of them. Automatically, you're already getting a mental picture of what this can do for you, of how the data set looks like, or the practicality. It just does what it says. Just describe the data set. Now, if you notice here, we have two formulas for each of them. If you notice, for me, I gave two formulas, this and this. For variance, we have two formulas too. Now, what's the difference between these formulas? Now, in data analysis, we have grouped and ungrouped data. Group data have frequencies and ungrouped data doesn't have frequencies. So if you are dealing with a data set that is grouped, you use this one with F here. And if you are dealing with an ungrouped data set, you use this one. If you are dealing with a group, you use this one. with the one group to use this one, on group to use this one. For the purpose of this course, we'll basically or mostly be working with on group data, but it's good I mention it. And let me quickly show you how they look like practically. So now this is an example of on group data. This is just normal data, and this is group data. Let's say 100 appeared 4 times, 102 appeared 6 times, 118 appeared 15 times. Now in reality, you're mostly going to be encountering this type, so we're going to be dwelling more on this during this course. It's just good I mentioned it. Now there are other descriptive statistics you need to be aware of, minus the mean, median, mode, and all those ones I've mentioned. Another one is skewness. What does skewness mean? Skewness tells us, okay, tells us the direction of the data set. Are more people towards the lower part of the data set, or are more people towards the higher side of the data set? For instance, a normal probability plot looks like this. This one here is how a normal plot is supposed to look like. That means if I plot any normal situation, maybe the height of people, I'm supposed to get something like this. Few people should be very short, and then few people should be very tall, extremely tall. Then most of the class or most of the people should be in the middle of the data set. The same thing with a standard exam score. So if you are a good teacher, or let me see, a typical exam score, most people are supposed to be in the average, then very few people should be very poor, while very few people should be very bright. That is exactly what we mean by that. So in a situation whereby, like for this now, where most people are tilted towards this direction, you will notice that. So if this is a test score and most people are towards this direction, it means that most of the class fails and few people pass. So if it's positively skewed, it means that most people fail and few people pass. And here, if it is negatively skewed, it means that few people fail and most people pass. And now for kurtosis, same thing. Kurtosis is also another descriptive statistics. What does kurtosis mean? Kurtosis means that look at the normal probability. So this one, the middle, normal distribution plot. Sorry, not probability. I've been mistaking it. This is a normal distribution plot. Even with the former example, they are called normal distribution plot, not normal probability plot. Beg your pardon. Now here, look at the negative kurtosis down this way. This negative kurtosis, it means that the data sets are very sparse. Then positive kurtosis means that the data sets are very, they are all compressed towards the mean. So even if you know the mean and you know the kurtosis and the skewness, they are going to give you a deeper idea on how the data looks like. Remember, the aim is for you to describe the data set, so as somebody who is just seeing it will understand where you are going to in your data set. Now this is a normal probability plot. Yes, this is what I've been explaining earlier on. So these are just how it is recognized statistically. Our first division should be -1 plus 1 deviation, standard deviation from the mean. This second one is 2 and 2 here, 2 standard deviation from the mean, 3 standard deviation from the mean. Don't worry if you don't understand this. It's okay. If you don't have a background in statistics, it's okay not to understand this. But basically, I just want you to know it exists, and this is what we mean by normal probability plot. And then if you have a background in statistics, you understand all these standard deviations below, and they are just more like percentile. Now these are scatter plots. Scatter plots are also very important plots that I will be using during this course. It just helps you to describe the relationship between two variables. So if I have a variable x and variable y, let me say height and width, and I want to check whether they are related, I can just plot a scatter plot to check whether there is a relationship between them. And we'll see all that when we start the practical section maybe even in the coding aspect when we start our Python and all that. During the Python class, we'll learn how to plot all the graphs. Then our box plot is very important. In our box plot here, we have our minimum, we have our maximum, we have our range, lower limit, upper limit, and then outliers. Outliers are data sets that don't follow, like for instance, a dwarf in that example of height. It's going to be an outlier. Somebody have giantism, it's going to be an outlier. It doesn't follow the normal pattern for the others. And these are median, which is our Q2. These are lower quartile and upper quartile, where I explained it before. And this is our minimum and our maximum, excluding the outliers. So this box plot is also a very important plot that we will be discussing during the course of this course.
Now, these data sets, these are data sets. This data set is the height of the average height of all the countries in the world. So we have height from male in centimeter, height of female in centimeter, male in feet, and female in feet. So this is the height by country down to, so this is just the height of different countries of the world, arranged accordingly. So the average height. So we want to describe this data, right? We want to just describe the height of people in the world. We're just using this just as an example. This data set is from cargo.com, and if you need it, we'll definitely send all these resources on the group chat. So for now, we have our mean. So now let's get the mean height of the male in the world. So I want to find out what's the average height of males in the whole world. So we're going to be picking the mean of all the whole male in centimeter now. So now there are a couple of ways we can do this, but in this place, okay, sorry, this is supposed to be formula bar. In this case, I'm going to be using the formula tab. So by the time we go to the formula tab, now these are using AutoSort. We can use this, or we can come to more function statistical, since we're doing statistics, and we go to average. Now remember, average is the same thing as mean. So if I click on this, okay, sorry about that. My cursor, your cursor needs to be where you want the answer to be. My cursor was here. I don't want my answer to be here. That is very important. Thank God I made that mistake so that I can emphasize on that. Your cursor should be where you want your answer to be. So I can come here now, more function statistical and average. So from there I can just come here, click on this, Control Shift down and click enter. Boom, I have this. Now what about maximum? Maximum follows the same principle. I can come here, statistical, then go to maximum. Now maximum is max. If you are not sure, you can just keep your cursor and see what it will tell you. Return the largest value in a set of values. Ignores logical text. Ignores logical values and text. So if there is if there is an alphabet, it will ignore it, but it's going to check only the numbers. So you can work with that. That's what we're looking for. So we delete this and we go back up and highlight this. Now how am I highlighting this? You can use your normal highlight like this, but I don't like using this. There's a shortcut for this, which is Control Shift down. See the way I'm dragging it? I just picked it and I'm dragging it. I don't like using this approach. The next time I'm going to show you the shortcut I used earlier. Okay, so if I click enter, that's giving me the answer. Now for minimum, the same thing. I'll come here, statistical, go to mean, this is not what I want. I picked mean A. What I wanted is just the normal mean. So let me go back there again. Return the smallest value in a set of values. What does this one do? Return the smallest value in a set of value. Does not ignore logical values and text. So we want this one. So I'm going to click here. And then I'm going to go up. Now see what I'm going to do. I'm going to just click on this first one. I'm going to press Ctrl Shift down and it will highlight everything for me. And I'll click enter. Now variance. Remember we also talked about variance. So I'm going to go to more function, statistical. Now variance, we have two types of variance. We have variance for population and variance for sample. So in this case, I'm going to use variance for population because our n is greater than 30. When the number of samples you are using is greater than 30, you use variance for population. When it's less than 30, you use variance for sample. So I'm using variance for population. Now in this place, I'm going to select what I want to find the variance of. I'm going to come here, take this, Ctrl Shift down and enter. It has given me the variance. And then I'm also going to do the same thing for the standard deviation, statistical, and then standard deviation. You can guess it's going to be somewhere around S. So look at it here. Calculate the standard deviation based on the entire population. So we want this. So we are now going to highlight what we want to do. So we're picking from here downward and we click enter. So that is the standard deviation we are talking about. Now for some of these other ones, even from our home tab, we can do some of them. This is our home tab here. We can do mean, maximum, and all that, sum and the rest. More functions. We can, but for all these other ones, I'll prefer you use the formula bar. So for average and the rest, you can easily use them. These ones here, but you won't see variance and standard deviation on this one. So that's why I just prefer to use this. Now another thing is that if you know the formula, you can type it directly. For instance, now we know that mean is equals to average, so I can come here and do equals to average and click on this and then highlight what I want. So it also feels possible. So remember, we're finding for female in centimeter. So let's check whether male or female, which one falls taller in the world. So let's just check. We can subsequently, we're going to do test of analysis, like where we're comparing these heights statistically, because in statistics, the fact that this is higher than this does not mean that there is a significant difference between their height. You still need to prove statistically that this difference you notice is significant. That means it's actually, you can bank on it. It's not just by chance. So that's what we mean by significant. So, but basically from what we're seeing here, it's obvious that the males are taller than the females worldwide. So, and also for this minimum here, we have female here. So let's calculate the maximum female height and see. So remember I say we can type the formula, so it's going to be equals to max. If you remember, the formula was just equals to max. Then for female here, I'll just come here, pick it downward and enter. Then minimum is going to be equals to mean, open bracket, this downward, and then standard deviation. If you remember, it was what, var.p, which is this one. So if you can remember the formula, you can just type it. But if you can't remember the formula, just follow that normal way and go through them. And even from typing it, you can also check whether that is what you want. For instance, if I come here now and I do equals to STE, okay, look at what we're looking for here. If I click on it, you see calculate the standard deviation based on the entire population given as an argument. Are you seeing? So this is what we want. So I can just pick this and now highlight the standard deviation for the females, and we have something like this. So these are basically two ways we can go about it. Now there are many more functions, as you can see under the statistics. As you can see here, there are so many functions. In time during this course, we're going to treat some of them. We're going to be treating some. We might not treat everything. We will not treat everything, but we're going to be treating the important ones. And with time, as you encounter anyone, just come and check here. Definitely you're going to find what you're looking for here. So this is one way of doing it using our formula tab. Now there is an easier way of doing this. We have another way of doing this descriptive analysis. Now if you check, this one is a bit time consuming, and it's taking our time. There is another easier way of doing it, which is using our data analysis toolpack. Now data analysis toolpack is an add-in in Excel. Remember I told you that in Excel we have the normal Excel. This is the normal statistical functions that come with any general Excel. But now, since you want to customize your own Excel specifically for data analysis, then there are some tools you need to activate. One of those tools is data analysis toolpack. That is the first add-in we're going to be using in this course. So let's go to this page and let's activate it. How do you activate it? If you check, mine is already active. That is this data analysis tools. So if yours is not active, go to data and check. If yours is not active, if you have never used it before, definitely it will not be active. Or if maybe someone else have used it on your laptop, you might find it active. But if you don't find it active, don't worry, it's very easy to activate. All you just need to do is to go to file. Once you go to file, go to more. Is it more now? No, not account. Go to options. Sorry, from more you go to options. So from more you go to options, you go to add-ins. It has been a while. So from add-ins, you will see this analysis toolpack. Now what this does is this. The thing is, while Excel don't bother to bring it, because most people will never use it. Maybe someone who uses Excel for engineering, or someone who uses Excel for programming, or someone who uses Excel for general office work, or someone who uses Excel for financial analysis might never necessarily need it. So in order to not to compact your computer with not to fool your RAM, so they keep all those things aside. So if you need it, then you activate it. But if it's something you're not going to need, then you can just leave it there, so that your computer can be more efficient, so that you don't cloud your space. So but for now, we will be using it. So you just come to an add-ins, click on this, then click on go, not okay, click on go. So once you click on go, look at the tool here. You can tick all of them, or you can tick analysis toolpack for now. So when you click on it and you click OK, automatically you will find yours active here. If you encounter any issue, please don't forget to ask me on any of the admins and definitely we will attend to you, or you can drop it in the comment section and we will definitely, in the comment section of this video, and will definitely attend to you. So now that we have activated it, let's click on it. So click on this, you're going to be seeing a lot of analysis here. So in this case, we want to do descriptive analysis. So let's look for descriptive. Where's my descriptive? Okay, I can see it here. So I'll click on OK. So it has popped up. So we want to describe our input range. So we want to find the want to describe the mean height. So I'm going to click down, label in first row, yes. So I want my answer output range. Now this output range, if you want it to be in a new worksheet, you just leave this, but I want it to be here. So I'm going to click here, output range, and I'm going to select this place. So I'm going to click OK. It said I should choose at least one statistical option. So I want my summary statistics. Sorry, I'm supposed to pick this. So let's pick our summary statistics and just click OK. So now it has given us our output. To understand, to see it better, all we need to do is to go to our home tab, go to format and auto fit column width, and we now have a summary statistic. So are you seeing that automatically it has given us our mean, it has given us our standard error, it has given us our median, it has given us our mode. We didn't even look for this one, but all these ones are also possibilities we can find in the general Excel, in that formula bar. All these things are there, but we need to look for them one by one. But in this case, we just give it to us at just one click. So here we have our standard deviation, sample variance, kurtosis, skewness. Remember when we did kurtosis and skewness when we're doing our theoretical aspect? So it means this is negative, our kurtosis is negative, that means it's flat. That means our normal probability plot is flat. That means they are very sparse. And all that, these are our skewness, these are our range, our minimum, our maximum, our sum, and our count. Are you seeing that this has successfully given us all that we need? So we can also do the same thing. Instead of doing them one by one, if you quickly want all of them, you can just use this data analysis toolpack and get all of them at once. Let's check. So you can compare the answers. If you compare the answers, you discover number of variance here is 24.37. What do they have here as the variance? The variance here too is okay. Here they used sample variance, not population variance. Here they use sample variance. That's why you can see this small discrepancy, 24.5, while that one was 24.37. So what they used there was sample variance. So we can, if we check, remember I told you that we have two types of variance, sample variance and population variance. So by default it does sample variance, but if you want, you can replace it. If you are doing maybe population variance, you can replace it with whatever you get from that formula bar. And so that is it about the data analysis toolpack. I will advise you check them one by one, and if there need be, we can still, let's check our mean. Our mean is 173.089. Let's check what we got from here. 173.089. You see that they are similar. So let's just try one more analysis here. I forgot to do. Let's just try, for instance, mode. Let's say I want to find the mode. So what do? We come to our formula. Remember, we go to more function, statistical, and we look for our mode. We look for our mode. So mode single returns the most frequently occurring or repetitive value in an array or range of data. So this is what we want. So let's look for this mode. It's giving us our mode to be 170.67. Let's see what this one gives us as the mode. 170.67. So are you seeing that they are the same? Let's look for this, for the variance of sample. Variance for sample, so that you will see that the difference there was just because they used for sample here. So let's look for variance for sample. So let's pick this. Using 24.5, which is exactly what they have here. 24, where is it now? Okay, 24.5. So basically, personally, I prefer this method. So you can just work with this method using your data analysis toolbar. It's easier and it's faster and it's more efficient. So let's look at the X-ray statistics. X-ray stat is also another add-in that we're going to use in this course, and it's Control M. For you to activate it, you use Control M. Now if I click Control M on my keyboard, this thing pops up here. Most likely if you click yours, it might not work because you have not activated the add-in. But let me just use it and show you something. If I click OK, so in this case, this one is much more powerful than the data analysis toolbar, because in this case you can add plots and what have you. So input range, let's just say we have our input range to be this, and we have our output to be this. Okay, let me just leave this. So we click OK. So it has given us, number one, our box plot. Remember when we learned box plot? So it has given us our box plot, and if we check up, we'll see where did it keep the output. Okay, look at the output here. So are you seeing the mean, standard deviation, count, sum? Now this one added some other advanced statistics, geometric mean, harmonic mean, and for those of us who will be tilting more into statistics, so when you are looking for the harmonic mean and the geometric mean, you can use this, because the normal data analysis toolpack will not give you that. And all these are our quartile, our Q1, so these are our interquartile range, our what do they call it now? This is our first quartile, it has a name. This is our third quartile and all that. So this one goes a step further than the analysis toolpack, that is the X-ray statistics. This video is getting really long, so I'm not going to show you how to activate it in this class, but in our next class I'm going to show us how to. I'm going to drop a video on how to activate your X-ray statistics, and I'm going to send the file to the group so that you can use it to activate it. There is a file that you need to put in your Excel for it to be able to work. You don't just add it through the add-in. If not, I would have easily done that. So I'll stop here for today. So we'll see in our next class. So I hope you got what we have. Please, if you have any question, please drop it. If there's anything you don't understand, please let us know, and then Personally, I will also drop an exercise file for us and like an assignment, and I'm going to drop it so that you guys can play around with it. Remember, I promised that the best 10 persons, I'm going to, in my best 10 students, we're going to create a platform for you guys. We'll add you guys into our freelancing platform. So anytime you get jobs, we can easily assign it to you. And anytime you do it, you will get paid for it. That's if you are chanced to do that. So please, let's attend to the assignment if you are chanced. I would really love to see if you got what we did today. So I'm going to send the assignment, and the assignment you'll be asked to find the descriptive statistics of the data using the formula tab and using the data analysis toolpack. And if you wish, you can also use the X-ray statistics. So thank you, and have a nice day.